In part 1 of tutorial 4 we looked at comparing measured and modelled data. Now what I'm going to show you now in the second part of day 4 practical is how to calculate flow rates through a cross-section. We're just going to focus on the modelled data, but as part of your validated exercise, part of your assignment, you might want to compare this with the ADCP data we collect on the boat. So in the process of doing this, we've looked at the calculator before, but now we're going to look at how we use the calculator for 2D fields. We're going to look at how we create a vector field, use the mathematical integration tool, and then how we extract data across a profile using an open line. So what is a flow rate? Well, it's just the volume of fluid which passes through an area in time. So we might look at the amount of water passing through the sort of mouth of Southampton water. The SI units are meters cubed per second. And essentially it's determined by multiplying the velocity field by the cross-sectional area. So from the model results we need the velocity, u and v, and we need the water depth to get the cross-sectional area. And make sure that you've saved depth when you ran your model. If you haven't saved depth, then you can always calculate it. It's just the free surface minus the bottom. So let's load in our model simulation again. Our Southampton reel, the first one we ran on day 3. Okay, now what you can see is I've got water depth there, but had I forgotten I could just minus the free surface from the bottom and get it. Okay, so what we're going to do is select the velocity u and v, click on Tools, and go to the calculator. And we're going to multiply the u component of velocity to start with. So let's go to velocity and select the u component for all time steps by the water depth here. And the expression is just A times B. And we're going to call this U and H for depth. The units are meters squared per second. And we can go evaluate. Now save that variable. I'm going to save it in day 4. In the base directory of day 4, and we'll evaluate that. It might take a minute because it's going through each of the 1,444 time steps. And in a minute you'll see the variable being created here. So you can see the variable created there. Now what we want to do is just repeat that process, but this time for the V. So there's our V, water depth, A times B, call this one VH. And the units are meters squared per second again. Let's evaluate that. Just check I did that right, V. Yeah. Save that again in day 4. Okay, so what we'll have now is 2 data sets, which is basically every single grid point, the water depth at that point times by the velocity, u velocity at that point, v velocity at that point. And what we want to do is create a vector field that contains this information. So here this velocity is u and v, but here we've got u and v separately. So what we can do is click on the UH, for example, click on Tools, and then Create Vector Field. So our U component is there. We want to make sure we click all fields, and the V component is there. Yeah. Do make sure you click all fields, or else it will only do it for the first one. And click OK. And you can see we've saved now both of those vector fields. Don't know what happened there. Okay, now what I'm going to do is just open the georectified TIFF. So I need to go File, Import georectified TIFF from day 4. I'm going to overlay that on the 2D view, and now I'm going to bring in the U and the V. I'm just going to make sure that we can animate it and run through it there. So this is now the flow field, the U and V times the water depth. Okay, now what I'm going to do is zoom into Southampton. I'm going to calculate the flow rate through the mouth of the solvent here. Okay. So what we need is a new open line. There's a new open line there. And we're going to create a profile across Southampton water. I'll do it so make sure that there's actually water there. It doesn't go on that. Click on that icon again, and let's call this profile 1. We can leave the value there as 0. Okay. So there's our line across there. Now what we need to now do is integrate across this profile to get the total amount of water going across this profile. So if we go to the view, what we want to do is turn on the T3 mesh toolbar. That's there. And what we do is select profile and then press this integration item here. And what we're going to integrate is the UH plus VH for all time steps. And what we'll call this is flow rate profile 1. We can do this for multiple profiles. Meters cubed per second. Click OK. And again, this is doing an integration, so it might take a minute to go through that time scale. Okay, so now we can bring up a 1D plot and just have a look at that flow rate there. So that's the flow rate through the profile. You can see the units there. And you can see some interesting features which are probably to do with double high tide. So what we can do now is actually just compare this with our time series at Southampton. Now I started with a new blue canoe, so I've stupidly got rid of all of that. But what I can do quickly is just bring in the shapefile again, the Southampton tide gauges, click on the free surface, tools, extract time series at multiple points, select the tide gauges in Southampton, take a minute to extract. What I'm going to do is just put the water level time series under here so we can sort of see how it corresponds. Okay, remember what we do, we right click and go extract time series, and I know that this is the Southampton one, so that's the first one. So what we can do is pull that across and just have a look at this. And what you can do now is zoom in, for example, and look at the negatives coincide with the ebb tide, the tide going out, the positive coincide with the tide coming in, the flat tide. So what I'd like you to do is repeat this step, but for other regions within the estuary. So why don't you have a go at doing that for some areas where there's even faster currents through here, and have a look at how do these compare. Are these bigger or smaller than the ones across Southampton water? And that is the end of the second component of Practical 4.